Yes.
Where are we?
Here.
Why are we here? Not entirely clear. We are misfits thrust into existence by random chance, with no hints at all as to how we're supposed to make sense of it all. It's immensely bizarre. Here we are.
Hello, everybody, and welcome to the Here We Are podcast. Today, I'm at the University of Tennessee, Knoxville, with this beautiful scenery, and my guest, Paul Armsworth, joining me today. Paul, thank you so much.
Thank you for having me on.
So, tell us what you do. What's your title? What's your background? Give us your whole life story. When were you born? What was your first memory?
No one wants to know some of those things. So firstly, I wasn't born, I was assembled. That's what I tell the family. So I'm a professor of ecology and evolutionary biology here at University of Tennessee, Knoxville. I run an interdisciplinary research group that focuses on how we can address biodiversity loss and losses of ecosystem services. So we think about how to design more effective conservation strategies, more effective conservation interventions. We try to inform natural resource management decisions. And of groups who sort of work in those topic areas, ours is perhaps a bit unusual in that we specialize in bringing mathematical, computational, statistical tools to bear to try to address those issues. So how can we bring those tools to bear to understand better what's happening to the biota and to improve our ability both to live with the biota and in the biota?
So give us a little more of your background. How did you get down this path?
So I started out in mathematics. My undergraduate training was mathematics. For my sins, I have 2 PhDs, and the first PhD was actually in math, still on sort of applied modeling work. But I found I didn't have sort of enough of a handle at that point on the underlying biological mechanisms that were driving some of the things we were looking at. So I then went and got a second PhD in biology, and that led me to these sort of pressing problems in biodiversity loss, that facing the loss rates that we have, the phenomenon that we're losing species at 100 to 1,000 times the natural background extinction rate. I felt I can't just study biodiversity aspects for fun, but actually because we have major societal problems that need to be addressed.
And by major societal problems, that's a very sweet way of saying mass extinction, isn't it? Major societal problem. But there's
obviously a range of environmental issues that people might focus their efforts to address. That in this series, you've spoken to others who work on epidemics affecting humans and things. So you can bring these tools to bear on a range of questions. We've tended to focus on what are we going to do about the extinction crisis, particularly how can we. That has an element of sort of the societal choice. How much should we do? Actually, we tend to focus more on if you're going to take action, if you're going to commit resource, if you're going to spend time and effort, how can we help you to do that to have the biggest impact possible? Right.
So how in the world do you get down to a problem? So do you first mathematically try to figure out what is kind of causing the most? Are there sort of keystone problems or something that you're trying to pin down a top 10 list of the biggest causes of, say, biodiversity loss?
So I would say that if you ask me for a first, what's the first step? It's not any of those things, because those would lead you to solutions that probably aren't going to be implemented. If you ask me what's the first step is to talk with our partners. So we work with state agencies, we work with federal agencies, we work with nonprofits, sometimes we work with business, and talk about what kinds of decisions people are facing, what steps they're trying to take to improve things, and then go from there to, okay, I can understand that the decisions you're facing, I can see the kinds of problems you're addressing, the kinds of data you have. I suspect we might have tools that can help you analyze those data or arrive at systematic methods to make those decisions that are more effective than just human judgment on its own can be. People do well when the data, when it's sort of 3 or 4 kinds of data. But once you've got 5 or 6 different dimensions of data, once you've got data that have different characteristics, then it really challenges the human to arrive at what would be a good decision. Not the best, but a good decision when I've got to combine all these different kinds of information. That's where the mathematics, that's where the computer science, that's where the statistics can step in to help us arrive at decisions that are driven out of data to try to get the most perhaps bang for the buck or the most improvement in the plight of biodiversity or in losses of ecosystem services that we can for the resource that we've given to address them.
So when you talk about the multiple dimensions of data, can you expand on that a bit?
Yeah. So if we just took the biodiversity piece alone, as soon as you start asking questions about biodiversity, you have to confront very quickly, it's not one thing, right? There's not one agreed way to measure biodiversity. There's not one type of evidence that tells you everything you want to know about biodiversity. It spans the diversity of life. So it spans many different levels of biotic organization. So is it individuals? Is it populations? Is it species? Is it communities or ecosystems? And then some of the interactions that make those things sort of a complicated web. So we've got that richness on the biodiversity side. We've then got how good are our estimates of what's happening to those things. Sometimes we have direct estimates, but sometimes we don't. Sometimes we draw on other information. We might draw on information from satellite data where they don't tell us everything we want to know, but they have some information that's relevant for us. It may be that the information's there, but it's not sampled in a way that is systematic and organized like we might like. A lot of our understanding of biological diversity still is driven from decades, centuries of work by natural historians, wonderful data resource, but not sort of following formal effort, standardized effort protocols. So we have to live with the oversampling in some areas and undersampling in others and try to find ways to piece together the story of where is biodiversity and what's happening to it.
When you say standardized effort protocols, what's that mean?
So if you go and look, and you can go and find it, you can go and find where is, what do we know about where a species is? What you will find is we know a lot. So here we are sitting in Tennessee, we know a lot about, is it near Nashville? We know quite a bit about, is it around Knoxville, especially if you're looking in well-known parks or recreation areas, places that people go and spend time in nature. Those get studied a lot. If they're easy to access, if they're near roads, we know them well. But even
probably
here,
if they impact humans.
Yeah, but even here in Tennessee, there's all sorts of things we don't know about biodiversity, and disproportionately, it's in places that are harder to get to, ecosystems that are perhaps less, that take more work to survey, and then it's for critters that are just perhaps not as well studied or loved. So we do really well on birds. Around here, we do less well on fish and even less well on freshwater mussels in terms of how much do we know about where biodiversity is and what's happening to it.
So you're saying that part of the influence on that is like people tend to like birds.
Yeah. And so,
a little more than fish are a little less interesting in mussels. It seems like we're after brain function is what appeals to us.
And if we are depending, as we are, on sort of a lot of voluntary labor and time, a lot of rich but individually held expertise, as opposed to sort of some very organized government survey where everything goes out on a fixed sort of sampling strategy every few years, then we're gonna have those biases. And now there's ways to deal with it. There's statistical approaches we can use that work with it, but that's something that if you don't use those approaches, you could make mistakes, you could miss opportunities. Now, your question, Shane, was about types of data. That's just the biological data. Right? That doesn't say anything about, well, what does it cost to intervene in different places? What are the threats impacting biodiversity, and what do we know about how those are changing or may change in the future? What do we know about the efficacy of the actions we might take? So if we're gonna try to protect land, or if we're going to try to remove legacy dams that are affecting things in stream, what do we know about the efficacy of those actions for improving the plight of biodiversity that we're trying to address? So there are many other aspects to the data beyond just the purely biological resource. So in our group, we do spend quite a bit of time and effort thinking about how can we combine information on biology with information from socioeconomic sciences in order to understand those other factors that don't just live inside an ecology department.
Do you take looking at one factor at a time, or how do you combine those? So the two things that you've already mentioned, looking at impacts of biodiversity from, say, populations in an area, and then from that, if you're seeing some loss in some population, seeing what potential policy measures might have some impact on that population. Do you know what I'm trying to get at? Like, do you like looking at all of those dimensions? What's harder or easier for you?
So coming in with a strong background in math and data probably makes it easier to move across disciplinary boundaries. Mm-hmm. It's not uniform. I increasingly collaborate with some qualitative social scientists, and that's quite a bit harder for me. It's easier for me if someone also talks data, even if the data are data on people or data on policies. That's meaning quantitative data. That's an easier conversation to have. When it's qualitative data, I'm still grappling with how to integrate across that sort of very mixed method design more, and that's a place that I'm still finding my way. But coming with a quantitative background, moving between, say, conversations with ecologists and economists, or with more sort of quantitative sociology disciplines, that actually feels, when it gets to the mathematics or when it gets to the statistics, there are some different flavors, but that's probably an easier transition for me to make than it might be for some of my ecological colleagues who came more from natural history, right? So if you came into this field because you really love, pick your critter, like you really love crayfish and you know crayfish backwards, that might be a harder stretch to then find yourself in a room with a group of economists or policy scientists and try and have exchanges. But because that sort of upbringing for me was inside the mathematical methods and things, then those things are also riven through other disciplines.
Math applies to everything.
Yeah, and so the as do statistics, as does computation, and so that makes that interdisciplinary bridge perhaps easier for someone who comes out of that sort of shared methodological background. Where things do get different, and it actually affects the kinds of math and the kinds of approaches that arise, is when you're not just asking questions about, can I describe what's happening in the system? Right? So I'm not going out just to an ecosystem and I'm looking at, well, I want to see how the pollinator is interacting with the plant and how that's affected if a second pollinator arrives or a predator, right? That's neat. I'm going to describe that. That's important. That's valuable ecological work. But actually the mathematics you would use to do that, or the approaches you would take to do that descriptive work, they are distinct from those that have what I would call a normative flavor, where it's, yes, I've gone in and I've looked at a system, I've got rich descriptions, I think I can make predictions about what might be coming or how it might change. Still, that's a step removed from, okay, how am I going to intervene? And what are the most effective ways to intervene? That brings in a range of different tools and approaches. And so if you asked me, so what's hard or what's different or what's new and novel and exciting, and for me, those things tend to go hand in hand, I'm quite drawn by those problems that go beyond just describing a system to talking about how can we intervene, and that then drags in various other bits of math or computation that are new.
Is that, I'm curious, what is some of the harder parts to mathematically model? Because I think the intervention to me seems like it would be the most challenging to kind of mathematically model all of these human factors and make predictions based on what trying to implement some policy is. How humans are going to react seems a little more complicated mathematically than mathematically modeling pollinators.
Perhaps it's the interdisciplinarian in me. I don't think that any discipline has the monopoly on what's complicated, right? If I described to you, if I hadn't stopped at the plant, if I'd gone down to what's happening in its roots and the fungal symbiosis, it would also feel difficult and cross-scale and complicated. These things are hard.
Yeah.
They're hard whether you look more at the human end of it, they're hard if you look more at the biological end of it. I don't know that it's that one is easier. I think there is a need as a modeler to be humble about how just what you're predicting, what you're understanding, and what it's telling you about. So, for example, in analyzing policies, I've done analyses whereby governments were paying individuals to try to deliver particular outcomes on the landscape. They want them to change their land management, and then we would track through. And what does that mean in terms of the ecological system? And we surveyed their businesses, we chatted to them, we had a model of human decision making, we had a model of what happened in the landscape, but at no point did we consider that we were actually modeling and predicting human behavior. We were predicting some aspects of it, some things that were relevant to it. The thing we were actually exploring, I think, much more thoroughly was, in that situation, the government thought they were providing a particular incentive. Like, this is the signal we're trying to send. Mm-hmm. We were then exploring, well, is that the signal you're actually sending? Or are you sending, with your intervention, a signal that's not achieving or not aligning with what you wanted? So in that case, we did track it quite narrowly through economic drivers that an individual would face, because it was an economic intervention they were trying to use. And we were able to say, look, you think you're signaling this, actually you're not. You're incentivizing things that weren't what you intended. So you don't have always to model human behavior to help inform a policymaker of whether their policy is doing what it's intended to do. That if someone's trying to give an economic advantage to certain behaviors, you can still answer, is it going to give an economic advantage to those behaviors? It might not by the time you track it through many different aspects of a system.
Mm. So it's still, so say you're thinking about invasive species of fish or something like that, and what its impact is and a possible intervention. That still seems like there would be somewhat less confusion with if we implement this, it will have this impact on the fish, and there's going to be all sorts of unknowns and complexity. But it still seems like when creating things like I'm being very human-centric right now, but it still seems like with human policy, say putting in some sort of fishing restriction or something like that is something that is a lot harder to determine. Like, well, how is the wording of this particular policy going to take, or is this message going to get across in this right way? It just seems like it just seems so much messier to me. But
as I say, I'm not going to say one discipline has a monopoly on complexity.
I'm not going to force you to.
But there's often a lot more to draw upon than my ecological colleagues might be alert to or aware of. Right? There are rich disciplinary traditions in economics and policy sciences that can help us if we reach out and talk with them. So I cartoon a bit the scientific papers that will work incredibly hard to understand like rich ecological or evolutionary mechanism. And then in the last paragraph, will then say something like, therefore we should stop emitting greenhouse gases. That's it. Like really rich, like dietary study of this songbird. Therefore, we should stop emitting greenhouse gases. Where the policy prescription is cartoonish and will just be ignored.
Right.
And that doesn't have to happen, right? If we talk with those who are making the decisions, right? We talk about the decisions they're facing. We talk about the levers they have. So it's not just an academic discussion. It's with people who are actually taking these decisions, who need the support. You then talk with your colleagues about, okay, well, here's what we can bring to the table. What do you know about perhaps the economic incentives? Or what do you know about non-economic incentives? What do you know in your example you gave, Shane, about the wording of messaging and how people respond to that? If we bring these different perspectives to the table and we can work together and integrate them, then arguably we can give that decision maker more useful tools.
So it's election season, and I guess when the average person thinks about what someone they're electing is going to do, and you try to picture what their job is like, I guess I never really consider how much time might be spent, hopefully, interacting with various, say, professors at universities trying to
wrong choice of decision maker, right? So it's not often an elected representative. It's much more often, sometimes it's their staff you might talk with, but I would say much more often the decisions that are changing things on the ground are being made by people working inside federal agencies, whether that is Forest Service, whether that's National Park Service, whether that's BLM, by people working with state agencies, whether that's state agencies here in Tennessee, whether that's in our other neighbors across the Southeast, by people working in NGOs. These are decisions that are being taken that impact the biota all the time. So it's not the case that that elected representative, they're gonna, they might take, one vote on biodiversity in the space of their time in office.
Well, that's what I was like.
And we can talk about what that vote should be, but it's not a frequent outcome for them. But others are taking decisions all the time.
I see.
To some extent, these are individuals who are living and working downstream of those sort of congressional level decisions, then trying to implement what's been stated on paper, and will have like relatively thin amounts of text to go from to, okay, what does that look like when it lands on the landscape? So what will the Inflation Reduction Act funding look like when it lands on the landscape? What will the funding that affects the environment inside the infrastructure bill look like when it lands on the landscape? That decision is not taken by those who were having the vote. They will lay out in very broad brush terms. Someone has to implement it. And so it's much more often at that implementation scale where we would sit and be talking with people and say, okay, well, how can we help you? You understand your mandate, you know what you've got to do. What you're grappling with is how can you achieve it or make a data-driven approach. So talk with us about what you need, and we'll try and bring the data together in a way that support you.
So when it comes to, first off, I got to get this off my mind because there's a term that you threw out there that's now just stuck in my brain, which was it was very early on in our conversation. I can't get it out. I believe it was base level extinction. You said something about like when things are beyond.
Natural extinction rate.
The natural extinction rate.
Yeah.
Okay. So there's a just natural extinction rate through like just kind of what you'd expect through Earth's history. There's always species dying off. There's always some climate fluctuation, a volcano popping off here, some new species having really taking off in some area and wiping out a bunch of things, and probably a lot more species, far more species going extinct than new ones taking off, I would imagine. And so how do you, I guess that can't be accurate, but how do you measure the natural extinction rate?
Right, so evidencing the biodiversity crisis is harder than people give it credit for, right? So I know many people who've written, we're experiencing a biodiversity crisis, and if you sit down and you say, okay, so what's the data? Right? What's the nature of the data? I said to you on the walk over that I'm teaching conservation biology at the moment to our undergraduates, and that's actually lecture 1. Like lecture 1 is, here's the headlines, you all just take them for true. That's not what we're training you to do. We're training you to be critical. We're training you to be scientific analysts. So the first question is, what's the data behind that? And there's several steps to showing we're in a biodiversity crisis. We are, and the data, the evidence you get when you dig through is pretty clear. There's uncertainty because of the nature of what you're trying to show. So I gave you a range. I said 100 to 1,000 times the background extinction rate.
Background extinction rate, that's what it is.
But the steps are that you have to try and demonstrate are fairly well understood. So firstly, you have to come up with that background extinction rate estimate. The most common approach that's used to do it is to focus on, and there's some assumptions, some interesting math assumptions to get there. It's to focus on organisms that leave, so it's in the fossil record, organisms that have sufficiently many hard parts to leave a fossil record. You then make assumptions about how long organisms remain extant in the fossil record. So we can't say they're species even, it's more like morphospecies, particular morphologies that are consistently stored in the fossil record. They have a longevity in the fossil record in millions of species years. With particular mathematical assumptions, you can go from there to say, well, if species experience extinction in a fairly independent fashion, then can I get from that longevity in the fossil record to an estimate of a mortality rate for a species that if it also had a similar lifespan in the fossil record. So from that, you can build up a background extinction rate estimate. You still have to show, well, okay, how do you evidence that the current extinction rate is much higher than that? There are other ways to go at that too. You can recover some of it from genetic information too, particularly off an assumption that speciation and extinction before the extinction crisis were in balance. But then there's how do we evidence what's happening to its extinction rates right now? And again, there are different approaches. So there are approaches that look at, again, sort of well-studied faunas and floras where we have documented known extinctions. An example would be, like the sort of a textbook example would be losses of rail species across Pacific Islands.
Rail species?
Yeah. So actually reasonably good size ground birds that have the misfortune of being easy to catch and desirable to eat. But that also means they leave a record in midden piles. And so we can track across the islands how many of these did we lose. There are other faunas and floras that are also well studied. You can get extinction rates of plant species in the 𝕊𝕙𝕒𝕟𝕚 in South Africa, where it's a small area, it's been well studied, we can get how many documented extinctions in 100 years, not the millions of years. And that then gives you a rate you can compare to the background rate. Harder still is to make predictions about what's coming. That's where we have to do things like look at current rates of habitat loss or destruction. What do we know about how many species we lose, or what can we understand about how many species we lose if those loss rates were to continue? Or what do we know about species dependence on climate, and what do we understand to happen if those climates are no longer around for species? How many species would we lose there? So it's one thing to recreate the background extinction rate. That has challenges. We have to understand the current extinction rate. Again, that's also a very hard question. Probably the bigger uncertainties, though, are how well can we predict future extinctions as well? Right.
So when you're saying that an estimation of 100 to 2,000 times greater than the background extinction rate, is that also to say that kind of species lifespan is shortening dramatically? Yes. by that?
Yeah, I mean, a different way to look at it, that's in terms of sort of rates, right? But just think about what's happening. You have two dynamic processes. So it is dynamic that we're roughly in balance. If anything, actually, the diversity of life has been going up through time. So if anything, they're slightly out of balance in terms of growth. But we had these things in balance, roughly. And then, now one of them, the loss rate, is 100 to 1,000 times heavier than the rate at which things are being replaced. So you can look at it in terms of rates, or you can then think about what does that mean in terms of just the, if you like, the stock of species or the amount of biodiversity there is and the erosion that we're seeing in there from anthropogenic effects.
So 100 to 1,000. I mean, I've had a lot of people on here, mention, talk about biodiversity loss and talk about, us potentially being in the next great mass extinction, and those are all impactful things. But hearing those numbers 100 to 1,000 times, that's even more troubling than as troubled as I already was, people.
And you can bring it down to sort of numbers of species loss rates. I'd have to check the numbers for you based on how long we're talking. But while we are talking, I could show you the data to say, okay, during that conversation, here's how many species we lost from planet Earth.
Wow. Ballpark it for me. If we talk for an hour.
So if I focused on losses of species through tropical deforestation, it would be between 1 or 2 species during our conversation.
Wow. I feel like I'm wasting your time right now. You should be at work trying
But then there's the question, so where do we step into this, right? Which is, if so much is on fire, right? If there's so much crisis, firstly, there's no excuse for inaction, right? So that isn't, that's a completely irrational, oh, there's so much, we're not going to do anything. No, you have to step in, you have to take action. But still, it means that when you've got limited capacity, when there's only so much societal resource being made available for conservation, or when you're working with an NGO and they've got a fixed budget, or when there's a budget that's been created or staff time that's been created from a particular policy, that time, that effort, that commitment people have made, you need to focus on where it can have the biggest impact. And so that's where we try and help. Right, that there is not these aggregate loss figures, but then disaggregating it down to what places, what times, what actions could we take to have the greatest effect.
Just to slow things at all, because anything that we can do to slow down these extinction rates, at least buys people like yourself and policymakers and people working on this a lot more time to potentially collect more data, come up with even better solutions. And
so you've grabbed sort of the numbers, the 100 to 1,000 times. Now I'll admit, those are global numbers, and tropical deforestation is a big part of that. But we're sitting here in the US, we could talk about US specific numbers. A huge network of conservation scientists, particularly led through the actions of the Heritage Network, through NatureServe, have assessed large numbers of species in the US. So certainly over 50,000. I don't know just how far up we can go now. That was when I last pulled the data, it was about 53,000 then. And assessed them based on their vulnerability to extinction when considering a range of different criteria for evaluating extinction risk. And even here in the US, about 1/3 of species being considered vulnerable to extinction or worse.
So when you look at these, which I have many times, I peek at these various extinction lists of what are the different ratings that they give? I guess that's kind of controversial, right? What species is the closest to extinction, and the way in which it's presented as the most vulnerable species, at least to the public. If you just Google what is the most endangered species, that list of 100 or so that you're getting, like, is probably about the same 100 that you'd be getting like 5 years ago or so. Yet every hour there's a couple species going extinct.
So there's a couple of things there. So the first is again, we have to be humble. We have to recognize we don't know most of the species on planet Earth.
Right.
So if we've described, and again, the numbers vary by which study you take them from, but if science has described, say, somewhere just over 1.6 million, 1.7 million species, and again, we don't know just how many are on Earth, but we might say somewhere in the region of 9 to 12 million. So there's many more species out there that we have never described. So when I talk about what we're losing, it's estimates based on only knowing a fraction of the picture. Right, we may lose things before we ever know about them. So that's one. The other thing, though, about these ranking systems, you were siphoning off like a tiny, tiny extreme tail. And I would expect there to be some noise in there. I think these systems are actually much more important when looking at very large numbers of species. The example I gave, I said, people have assessed sort of over 50,000 native species in the US, not 100, but 50 to 55,000 species. And there, it's not like who is the most vulnerable, it's more broad classes. So it's, yes, there are classes like who's imperiled and who's critically imperiled. There's who's vulnerable. There's who's actually doing okay, who's secure. And where are we data deficient? So it's not about just finding that extreme tail, it's more about understanding what's happening to the whole of the biota, which can still talk to us about where there's scope to act. So we're sitting here in Knoxville, and we can't quite see, we want to be over that way a little bit, but on a good day you can see the mountains in the background. For the interior US, the central and southern Appalachian region is actually a hotspot of biodiversity for, particularly for a number of taxonomic groups. If you look at a map of sort of where biodiversity is, you'll find places like that light up. So it's not the case that we can act everywhere and have the same impact. We can act everywhere and have an impact, but there are also quite special places whereby taking actions can achieve particularly high impact. And so that's where can we identify those. And that was a straight biological statement, but you could combine that with information on, okay, and how many, what do we know about the opportunities there? And what do we know about the cost of taking action there? And what do we know about the threats of loss in that location versus other locations? So there's those sort of aggregate pictures, but to really help inform actions, we need to then disaggregate that to say, okay, where, when, and how can we best intervene?
So you can see some of these hotspots of biodiversity on a map, if it's Amazon or Appalachian region or something, and my sense is overall they're shrinking pretty quickly, right? Or they have been.
So when we talk about them, we're often talking about spatial regions that are important. So I wouldn't necessarily expect the spatial regions to shrink. That's the shrinkage is more the loss of biodiversity inside those and other places. So there will still be places on the map that even as we're losing biodiversity remain critically important.
Right.
You may find there could be more, but often one sort of sets a threshold criteria, a bit like your 100 species. It's not normally 100 species. It might be very relevant to current policy debates. Where are the best places? I'm being careful not to say national, but you might say where are the best 30% of places in a state, or where are the best 30% of places in a region to try to improve things for biodiversity.
So each region, what is impacting biodiversity loss must have a variety of factors in and of itself, and there's probably what is causing biodiversity loss in some region of, like, say, Scotland, where you're from, or something, and what's happening in some region in, say, Brazil or something, just randomly saying a place, is going to be different overall. Or how many of those issues are just universal issues, something like, the Earth is warming and it's causing this, just kind of in most regions around the world, as opposed to each region having these very, very, very specific, nuanced impacts that are influencing biodiversity loss?
So the drivers are well known, and the drivers are general, and they're global. They vary in their relevance based on like which ones are more important in this place than that place, and they act synergistically. So the drivers, though, are common and well studied. As I say, they might vary in their importance. Different answers on island ecosystems than marine ecosystems, but we know what they are. The thing that has more context dependency is often the sets of options to intervene. We often have worked on things that are tied to policies or legislation, and those don't move, right? There's like the laws and regulations, the institutions are often particular to a nation or a state or a region, and that's where you can have more context dependency. The biota is different, and there's context dependency on how it reacts, but still the actual drivers of why are we losing species, while they vary in their importance in different ecosystems, we know what the candidates are, we know where to look for them.
It hit me with the major player.
The ultimate driver is always, the one to always go back to, is a combination of human population growth and consumption trends. At the end of the day, if human societies are appropriating only like a significant proportion of the energy resource available to support life on Earth, that energy resource is not available to the rest of the biota. And so the ultimate driver is human population growth and consumption trends. That shows up as more direct drivers. The more direct drivers would be habitat destruction, fragmentation and degradation, spread of invasive species, overexploitation, and again, different importance in different systems. There's also changing sort of biogeochemical cycles, pollution type issues, and there's climate change. And so those drivers are all well understood. As I say, they vary in importance based on which bit of the biota you're looking at and where you're looking, and importantly, they act synergistically. So it's not about this one versus that one, it's the combined effect of them.
But when it comes to various interventions, there's more diversity in terms of, I imagine what can be done in Scotland versus Brazil is very much dependent on the differences in various agencies that exist there, and probably economic concerns. I'm sure that there's regions in the world where nations, for example, may have far more resources to maybe try to implement change, whether they do or don't. They might actually have the ability and resources and technology to do so, in some regions that really don't have the resources to make that nearly as much of an impact. And so there'd be some constraints there and very different considerations that you'd have to make in terms of what kind of interventions are realistic in a region.
And so in our work, we've tended to be sort of often sort of worked in particular regions, whether that is an ecoregion, whether that is a particular state, whether that is with a particular partner. And that's the bit, as I say, that doesn't generalize as readily, because it is often tied to the community, the place, the institutions, the mandates, the players. And if we want to inform actions, we need to embed with those aspects. And so that bit doesn't generalize as readily as say understanding what the drivers are. Mm-hmm. I think implicit in your comment as well, Shane, and so we need to sort of fess up to it and be honest about it, is that biodiversity loss is felt most acutely, or the places that have the most biodiversity and the most potential to help are not the places that have the greatest economic capacity to tackle some of those changes. Right. And so, like climate change, like other things, ultimately there is a global problem here, and there are aspects of sharing of responsibilities to try and address that. That discussion tends to play out sort of a level above, beyond talking with an actor with us, whether that's an NGO, whether that is a state agency, whether that's a federal agency, about what are you facing in this region, how can I help? There is in the background a conversation, a larger societal conversation about, okay, who bears the responsibility and how might as a society we want to address that. But I say not too many individuals are making decisions at those scales.
I'm curious, I mean, we would certainly have people listening that are wondering, well, what can anyone else do? Like, yeah, I'm not a scientist, I'm not a policymaker, I'm not in one of these federal organizations. What sort of things can the average person do other than just hear about all of the species that we're losing and be terrified by it?
So I think there's all kinds of things. So you can be alert to the environment and environmental issues in your voting. Often, if you look at polling on environmental issues at large scale elections, whether that's state or national, it's always in there, but it tends to be a lower priority for people than some other things. But there is important legislation that is awaiting action in the Congress just now that has some bipartisan support. That educate yourself about these opportunities, reach out to your congressional or Senate representatives and say, hey, both parties like this stuff, why don't you move some of it forward? There are opportunities there that could be taken. There's also often, depends on just what state you're in, there are often also local electoral measures that one can get involved in. So in the US, through the ballot process in those states that offer direct democracy on the ballot, huge gains have been made in terms of conservation and land protection through the ballot box, but on local measures. So local communities voting to implement measures that improve the plight of conservation issues nearby. So that's sort of a voting route. There can be a route in terms of membership organizations or donations to conservation organizations. So certainly get educated about what they're doing. Some of them do wonderful work. They do wonderful work right across the US. They very likely do wonderful work in the communities of your listeners that I suspect some don't know about. And so there's opportunities there to engage with local organizations through more of a membership or a giving route. And then there's volunteering opportunities as well that if you're interested in these things and you'd like to get more involved, but you want a more hands-on role, then show up at your local protected area. At the next day, they're offering volunteering opportunities. Get to meet the staff, get to meet the other volunteers. You will find there's a rich community there as well. There are some on the data collection side. There are groups going out, they're helping with surveying. There are others who are going out who are ripping invasive plants. So there's opportunities to be involved in a very hands-on way. All of that doesn't yet say, but we should think about our own footprint. So
our own what?
Footprint. So think about the choices that we all make every day. I make them, my family makes them. Think about when we're taking those decisions, the balance of how much do I need that, how much do I want that, what will that do for us, and what will its impact be. And sometimes there will be decisions that are consumption decisions that impact the environment negatively, but sometimes perhaps there are things we could not, or there's decisions we might not take because it would spare the environment that otherwise we would have done. And so there, I'm trying to outline that it's not that there's nothing someone can be involved in. I went from the democratic process through to civil society, through to individual consumption decisions, and there's a whole range of ways to be involved.
Are there any popular science books that you have liked that convey some of these ideas well to the public?
I don't know. I don't really want to pick winners. There are, because we've covered a lot of ground, there are popular science books that have been very impactful in terms of raising people's awareness of the extinction crisis, but those are quite different from people who are writing explorations of the landscape of those doing conservation. And those often have, because of that context specificity in the action side and the institution side, those often have still almost like a travel guide, like tourist experience, that someone is coming in and they're finding out, man, they're interacting with the environment in these very different ways. How you can manage conservation, what? And the human characters come to the fore as well. So I don't want to pick winners for you,
Okay.
but the partly because I would offend a lot of friends if I did. But there is a gradient. It shouldn't just be the doom and gloom. We're in a sixth extinction crisis. I would also encourage people to look at some of the ones that are people writing about those who are taking action on conservation, the exciting things that they're doing, and the promise and the opportunities it creates. And you'll find rich examples of both.
That you won't give us. All right,
Not picking
afterwards. Okay, I don't want to get you in trouble with your friendships. Just to get valuable information out to the public. Do you have any? Since you're not going to share your secret favorite books until we stop recording and you share them with me, now I really want to know. If people want to know more about your work, where could they go?
So we have a lab website. So if you look for armsworthlab.com, you will be able to see examples of the work that we do. As well, if you go to the Department of Ecology and Evolutionary Biology here at University of Tennessee, you'll see I have many wonderful colleagues who also work on some of these related topics as well, and I would encourage you to check out some of the exciting work they do too. They are better, the department is better than I am at social media feeds, but there are social media feeds for the department as well, so you can follow these things as they're emerging, as the new results are coming out.
And we'll include a bunch of links within the description as well. Thank you so much for joining me.
Well, thank you for the opportunity to chat to you this evening.
Yeah, and thank you listeners for being such wonderful, curious people. We'll see you next week.